Hey guys, this is Michael from Unique Tutoring, and today we'll be adding another video to our Let's Solve Math High School Edition series. Today's video will be on triangles. Because we know that A plus C is equal to 22 and 4 in triangle ABC, point R is the midpoint of BC. The distance from BR is the same as RC, so we can just draw these little ticks to just remind us that they're the same. There's another point S along AC such that SC is equal to 3 times SA. So we can write 3B here, and then we can write B here because it is 3 times the length of AS. And we have another point along AB, that is T. And AT is equal to P, and TB is equal to Q. And what we are trying to find is AT over TB, or P over Q. There are also 3 areas given. W is the area of triangle CRS, and we can just complete the triangle. And X is the area of RTB, and Z is the area of ATS. It is also given that x squared is equal to WZ. So now, with this information, we are trying to solve the question, what is P over Q? Because there are 3 unknown values, W, X, and Z, we need 3 equations to help us solve this. First, let's draw some imaginary lines to help us do this. So we're drawing an imaginary line from A to R. We will draw another imaginary line from T to C. Let's find the equation for W. So by looking at this drawing, we know that the length of SC is 3 times the length of AS. And in relation to AC, it is 3/4 the length of AC. However, let's prove that the area of W is 3/4 the area of triangle ARC. Now, we know that the area of a triangle is base times height divided by 2. And to help us out, let's draw an imaginary height here to help remind us. So this height is universal for triangle W and triangle ARC. When we are writing this out, the area of W, we get W is equal to 3B times H divided by 2. And for the triangle ARC, its area is equal to 4B times H divided by 2. Now, when we want to find a ratio between W and ARC, we can just take the area of W divided by the area of triangle ARC. And when we do that, we get a simplified 3/4. So now we can say that W is equal to 3/4 times the area of triangle ARC. Now we want to represent the area of W in terms of triangle ABC. Since R is the midpoint between B and C, if we drew an imaginary height here, then it would be the same. We would have the length of RC times height divided by 2, and the length of BR times the height divided by 2. And because these ticks remind us that these are the same length, we can therefore know that ARC is 1/2 of ABC. So then When we write W in terms of triangle ABC, we can write it as W is equal to 3/4 times 1/2, because triangle ARC is 1/2 that of ABC, and then we can times it by K, and we are using K to represent the total area of triangle ABC, and when we simplify it, we get W is equal to 3/8 times K. So this is our equation for W. For the equation of Z, we will do something similar to when we found the equation of W. If you take a look here of triangle ATC, we can see that they have the same side length, AC, as we had when we were solving for W. But in this case, Z only uses 1/4 the length of AC. So therefore, Z is equal to 1/4 times the area of triangle ATC. However, if we want to look at triangle ATC in relations to triangle ABC, we must look at what we did before to find the area of triangle ARC. So as you can see here, when we were solving for W, we had 3B compared to the whole length of 4B. So this is our ratio. Now we must take a look at the length AT compared to the whole length AB. So then we can write triangle ATC in relation to ABC as P over P plus Q times the area of triangle ABC. And this is our relation of triangle ATC to triangle ABC. Now we can just multiply these two together. So the 1/4 and P over P plus Q times the area of triangle ABC to get Z. And we get Z is equal to P over 4 times P plus Q times K, which is the area of ABC as we defined earlier when solving for W. So now we have the equation for Z. The last equation we must find is for X. When we take a look at X, we can see that its condition is very similar to that of W, because we have a sideline here, same as here, and we have the continuation of that line here. Also, we have involvement of midpoint R. Because we proved that triangle ARC is 1/2 of ABC, we know that ABR is the other half of triangle ABC. However, in this case, we do not have the lengths 3B and B. We have Q and P. So if we did exactly what we did for W, we would get X is equal to Q over P plus Q times the area of triangle ABR. And because we know that triangle ABR is 1/2 of ABC, we can write it X equals Q over P plus Q times 1/2 and then times K, which is our value for area of triangle ABC. When we simplify this, we get X is equal to Q over 2 times P plus Q K. This is our equation for X. Now that we have all three equations, we can plug in their values into the equation we were given at the beginning, which was X squared is equal to WZ. So plugging in the information for X, we have QK divided by 2P plus Q, and the whole thing is squared, is equal to W which is 3 over 8k, or we can just write 3k over 8, times z, which is pk divided by 4p plus q. Now we can just simplify. So when we are expanding, we get q squared k squared divided by 4p plus q squared, because 2 times 2 is 4, so we can just write 4, is equal to 3pk squared divided by 32p plus q. Because these two equations are equal, we can use the crossover rule, that is, taking this term and multiplying it with the bottom term here, and taking this term and multiplying with the bottom term here, to eliminate the division sign, and the equation will still remain equal. So when we do that, we get 32 q squared k squared times p plus q is equal to 12 pk squared times p plus q squared. So now our job is to simplify this equation in lowest terms. So we can start by getting rid of p plus q. So we divide p plus q on both sides. So this gets rid of the p plus q here. Since this is p plus q squared, we just get rid of the square. And now we just find terms that match, and we can get rid of them by simply dividing them out. So if we take the whole thing divided by, let's say, k squared, we can get rid of it on both sides. So k squared is gone. 32 is not divisible by 12, but we can reduce it by dividing both numbers by 4. If we do that, we can rewrite it as 8q squared is equal to 3p times p plus q. And now all we have to do is multiply this term into there. So we can get 8q squared is equal to 3p squared plus 3pq. And now we want to have all the elements, all the terms on one side. So we can just subtract 8q squared and move it over there. And we'll just write it on the left hand side. So we get 3p squared plus 3pq minus 8q squared is equal to 0. So we know that p divided by q is equal to some number we do not know, and we write it as a question mark. However, if we times the whole thing by q, we can isolate the p, and we get p is equal to question mark times q. So every time we see a p, we are going to rewrite it as question mark q. So we have this equation, we can rewrite it as 3 question mark squared q squared plus 3 question mark q times q again, so that would get us q squared, minus 8q squared equals 0. Now we can see what we need to divide by next a lot more easily. All three terms have a q squared, so therefore if we divide the whole thing by q squared, we can just get rid of it. And now we're left with 3 question mark squared plus 3 question mark minus 8 is equal to 0. So now we can plug our equation 3 question mark squared plus 3 question mark minus 8 equals 0 into the quadratic formula. And when we do that, we get question mark equals negative 3 plus or minus the square root of 3 squared minus 4 times 3 times negative 8, all divided by 2 times 3. And when we simplify, we get question mark is equal to negative 3 plus or minus the square root of 105 divided by 6. So the plus or minus just tells us we have two answers. We can either have positive root 105 minus 3 divided by 6, or we can have negative root 105 minus 3 divided by 6. This answer will obviously be negative. We know that p divided by q cannot be negative because neither of these side lengths are negative values. So, therefore, the answer must be root 105 minus 3 divided by 6. And there's your answer. Positive root 105 minus 3 divided by 6.